Today, we're going to be designing a popular system design interview problem, design a webhook service. This is a common question asked in interviews at big tech companies like Google and Meta, so let's go through how to ace this interview. First, let's clarify what a webhook is. A webhook is a communication method that allows one software system to automatically send real-time data or notifications to another system when a specific event occurs. Unlike traditional APIs, which require constant polling to check for updates, webhooks push the information as soon as the event happens. This makes webhooks both efficient and real-time. Now that we know what a webhook is, let's discuss what a webhook service is. A webhook service is a system that handles these incoming notifications, or webhooks. Its job is to manage the entire lifecycle of a webhook, receiving the event, processing it, performing necessary operations, and storing the results. To build an effective webhook service, you need to meet several functional requirements. First, the service must accept external API calls, allowing it to receive events like a payment being processed or an order being shipped. Next, it needs to execute the corresponding operations for each event. For example, if a payment is successful, the service should update the order status in the database. Finally, it must persist both the original event data and the results of the operations for future reference. This is crucial for tracking, auditing, and debugging. Beyond functionality, the webhook service also needs to be reliable and robust. Additionally, the service must provide an at least once delivery guarantee. This means every event must be processed at least once, even if the system encounters failures. However, this also introduces the possibility of duplicate event processing, which brings us to the next point: idempotency. Operations performed by the webhook service must be idempotent. This ensures that even if the same event is processed multiple times, the outcome remains consistent. Let's start with a basic design. When an external system sends an event via an HTTP request, the webhook service needs a request handler to receive and process the event. This data is then immediately saved into a database. While straightforward, this design has a flaw. The request handlers handle the HTTP requests as well as the business logic of processing and persisting the events. If the request handler fails after processing the event, but before saving it, the event could be lost. To address this, we can introduce a message queue between the request handler and the database. We reduce the responsibility of the request handler to handle initial HTTP requests and let the message queue consumer do the heavy lifting of processing the actual event. The message queue temporarily holds events, ensuring that no data is lost, even if the system experiences issues. The request handler now focuses on handling HTTP requests and enqueuing messages, while separate consumers process these events from the queue and save them to the database. This design offers several benefits, including failure recovery, load buffering, and scalability. Let's break down how these components interact in a real-world scenario. By the way, if you're enjoying this video and want the best practice website for system design interviews, check out our website at systemdesignschool.io. Now back to the video. The process begins when an external system triggers an event, such as a payment confirmation. The client server sends this event to the webhook service via an API call to the request handler. The request handler validates the event and enqueues it into the message queue. Once enqueued, the event receiver sends a success response back to the client server. Queue consumers then fetch events from the queue, process them, and store the results in the database. After successful processing, the event is dequeued, marking the completion of the process. Notice that the request handler returns 200 as soon as the enqueue operation is successful. This is to confirm we received the event. The service level agreement and requirement is to eventually process the event. This means our system must be resilient, designed to keep functioning even if certain components fail along the way. Let's explore how to maintain system functionality in the face of failures. This is an essential component in system design. Let's start with the request handler. If the request handler fails after receiving an event, but before enqueuing it, the client service will not get the HTTP 200 response. This way, the client knows to retry if necessary. For message queue failures, use durable queues that persist messages to disk and replicate across multiple nodes. This ensures that events aren't lost even if the queue server crashes. If a queue consumer fails, multiple instances can take over, ensuring continuous operation. Message acknowledgement and dequeuing the message should only happen after successful processing and database storage. Finally, comprehensive monitoring, alerts, and chaos engineering can help identify and address potential issues before they impact the overall system. Now let's dive into how to handle duplicate events. Duplicate events can occur if the external system sends the same event multiple times. The Webhook service needs to recognize and handle these duplicates to ensure each event is processed only once and to ensure idempotency. This can be done by deduplicating events in the message queue or by checking the database before processing an event. For example, Amazon SQS has message deduplication support. We can use event ID as the deduplication ID so that the queue can filter deduplicates out automatically. This offloads the work to the queue and simplifies our design. However, deduplication is typically supported in FIFO queues, which is slower than standard queues. If we want to use the more performant standard queue, we can use a simple in-memory database lookup with a TTL to implement deduplication. Finally, let's talk about security. Since the webhook is open to the internet traffic, it's important to verify the request is indeed sent by the trusted service. The most common method for securing webhooks is by using a hash-based signature. When you register your webhook service with Stripe, a shared secret key is generated. Every time Stripe sends a message, it calculates the signature using the secret key and the message body. This signature is then included in the HTTP header. When your service receives the message, it performs the same calculation using its copy of the secret key and compares the result with the signature in the header. If they match, you know the request is authentic. Thanks so much for watching this video. If you liked it and want to see more, make sure to subscribe to our channel and hit the notification bell to stay up to date. Also, check out our website at systemdesignschool.io for system design interview practice, complete with an AI auto grader. Thanks, and we'll see you all in the next video.